All right, everyone, welcome to section 6.6, solving equations by factoring. We're going to be working with some quadratic equations here and factoring those out and finding some solutions to equations. So some objectives today. So we're going to be applying the zero product property, solving quadratic equations, and solving applications using those quadratic equations. So the first kind of thing here is called the zero product property. Basically, what we're doing here is in order to solve equations, we use this property, which basically states that if I multiply two numbers together and the answer is 0, one of those two numbers, or both, right, has to be equal to 0. So this is how that works if I have some equations. So we're going to solve each of these. So basically what we're doing here is we're multiplying 3x and x plus 4. Now, if that answer is equal to 0, then either 3x equals 0 or x plus 4 equals to 0. And we'll see, well, what numbers make that true? So if I do this property, basically I'm taking each of these, the 3x and the x plus 4, and I'm setting it equal to 0. And again, it's either or both, okay? So again, what values of x make that true? Well, we have to go back to algebra a little bit, solving equations. So how do we solve 3x equals 0? Well, we just take and we divide this by 3. And we get x equals 0, right? Because 0 divided by 3 is 0. Or in this one, x plus 4 equals 0. To solve this, we would have to subtract the 4 to both sides. And so x is equal to -4 here. So either x equals 0 or x equals -4. That's the values that would make that equation true. And actually, the way that they want you to do it in my math lab, or my lab math, whatever one you want, is to write it in a comma separated list. So they would want you to write x equals 0, x equals -4, comma 0, or 0, comma -4. I don't think it really matters, but this is kind of what they're looking for there. In this one, again, all you have to do once you have it factored, and in a little bit here, we're going to get into some equations that haven't been factored. But once it is factored like this one, we just set those factors equal to 0, and then we solve for x, or whatever your variable is. So this one, I would add 1 first, and then divide by the 4. So x equals 1/4. Or in this case, I would subtract 4. So give me 3x equals so that's a -4, and then divide by 3. So x equals -4/3. So it's really x equals -4/3, comma 1/4. So each of those options would make this equation true. All right, let's get into solving quadratic equations now. So these haven't been factored yet. So basically, the whole point of this is that the equation has to be written in standard form. Okay, that's the point of this slide right here. So standard form is ax squared plus bx plus c equals 0. So your x squared term is first, then bx plus c. So this is called a quadratic polynomial. Note that a cannot be equal to 0, because that would make this first term 0, right? 0 times x squared would be 0, and that wouldn't be a quadratic anymore. So we have to write it in standard form. So basically, when we solve quadratic equations, what we're going to do is, first step, we are going to write the equation in standard form. And then we're going to factor, right? Once we have the factors, we're going to apply the zero product property like we just did in the other example. And then we're going to solve and then check. So let me model that for us. So we have this quadratic equation, 36 plus x squared equals -12x. I want to basically move everything to the left side so that it looks like ax squared plus bx plus c equals 0. Okay, so everything on the left, 0 on the right. Well, x squared and 36 are already over here. So I'm going to write it in order, x squared. If I want to move -12x to this side, I'm going to add it, right? So it's going to become plus 12x. And then plus 36, since this was positive, equals 0. Again, all I did was I added 12x. Okay, so hopefully you can see that. Okay, so I just did plus 12x. And then over here, it doesn't, I'm not going to put it under any term because it's not a like term with either of these. And I can just put it right there. And then now this is actually a perfect square trinomial. So I can actually break this up into x plus 6 and x plus 6. So this is the point where we have to factor. Once it's factored, now we can set those equal to 0. Well, this is the same thing, right? Both these x plus 6s are the same. So I could just combine it here like so. And then to solve this, I would actually take the square root because it's a square. So I'd have x plus 6 equals 0. Well, then x equals -6. Okay, and again, if I want to check that answer, right, this is going to be my check. I just take the original equation, 36. It should have been a plus. Write that 6 too. Rewrite that. So it's going to be 36 plus -6 squared, right? Does that equal -12 times -6? So I'm not going to check it every time, but this is what you would do. You would just plug it back into the original, and it does end up checking out. Okay. So -6 was correct. All right, another quick example here. We notice again, and you just kind of have to go back to your factoring rules. We notice that this one is a difference of squares. So I can factor that as x minus 7, x plus 7. Once it's factored, take each of those factors. Okay, set them equal to 0 and solve. So x minus 7, I'm going to add 7 to both sides. So it's x equals 7. X plus 7, I'm going to subtract it. So I'm going to get -7. So x equals 7 or x equals -7. So again, in my math lab, we're going to put it into a comma separated list. All right, another one. Again, step 1, make sure it looks like a quadratic equation, right? So ax squared plus bx plus c. So we're gonna rewrite this. I'm just gonna add 5. I'm gonna add 5. Okay, so it looks good. And now this is a trinomial, but it's not a perfect square trinomial because 2x squared and 5 are not perfect squares. But then, so what I can do, remember going back to factoring, this is just review, is I multiply the 2 and the 5. So 2 times 5 equals 10. And I want factors of 10 that add to -7. So that would be 2 and 5, but those both have to be negative. So I split the middle term, which is -7x, into -2x and -5x, or just -2x and -5, and then plus 5. And now I can factor this by grouping. Okay. So if you don't want to do this step right here where I kind of group these terms together, you don't have to do, you don't have to kind of write that out. If you can kind of do that in your head, that's fine. But I just write it out just because we can all stay on the same page. So in this parentheses, I can take out a 2x, which leaves me with x minus 1. And then this parentheses, I can take out a 5, which also leaves us with x minus 1 to get back to the plus 5, like we've talked about. And then I can combine these x minus 1s into just a single x minus 1, because those are the common factors. And then I have the 2x minus 5. Now it's all factored. So now I can, let me just come up here. So I can just go either x minus 1 equals 0, or 2x minus 5 equals 0. So here I just add 1. So x equals 1 or plus 5. And then divide by 2. Oops, 5 halves. That's just 5/2. Let me rewrite that. So people who are you're just looking at these notes and you're not watching the videos, you can kind of come back to it later and know that that's just 5/2. So really it's x equals 1 or 5/2 or 1 comma 5/2. All right, a couple of word problems here. So one point of doing these is when we get to, I believe it's chapter 8, when we get to graphing and solving quadratic equations with graphs. So a parabola, right? So a quadratic equation is going to make a parabola, if you remember that from algebra. But we need to know how to solve those first before we get to those kind of problems. So in this case is if a model rocket is launched at 48 feet per second, then its height h after t seconds is h equals 48t minus 16t squared. So that's the equation that models that rocket launch. After how long does the rocket strike the ground? Okay. Well, one thing we would need here, so if this is the equation that models this situation, okay, the last sentence says after how long, so that would be our time, right? After how long does the rocket strike the ground? Well, when does the rocket strike the ground? Okay, well, it would be when the height is what? Well, that would be the height is 0. Okay, so what we do here is we just say, okay, the height has to be 0. And then I can solve this guy. Okay, and it'll give me some options for time. So let's go. Oops. I don't know what just happened there. I was writing and then all of a sudden, or not writing, and then all of a sudden it started writing. Okay, there we go. So let's see here. So let's try and factor this guy. Well, I can take out definitely a 16 from 48 and a t. Helps to be good at your multiplication skills. If you're not, look at a multiplication table, or you can just try it, right? Does 16 go into 48? Yes, it does. So then I have a 3 and a t left over. So that is completely factored. And now I'm going to split this up. So either 16t equals 0 or 3 minus t equals 0. And notice I'm just writing it on the other side. That doesn't really matter. If you wanted to switch this around right away, you could have. Okay, but so if that's confusing for you. But anyway, either the time has to be 0 or the time has to be divided by -1 because a minus in front of the t is a negative. So either t equals 0 or t equals 3. Well, what would make sense, right? If you launch a rocket, the time, there's no way the time could be 0, okay? So this is kind of what we would call like an extraneous solution. It just doesn't make any sense. So time would have to be 3. So after how long does the rocket strike the ground? The rocket strikes the ground. After 3 what? Seconds, right? T seconds. We just found that one of the times was 3. So after 3 seconds. Wow, that was bad. Let me let me recircle that. Sorry. If you guys could see what I'm using here, I'm using a tablet that doesn't have a screen on it, and looking at my computer screen and writing. It's very, very confusing, and it took me a long time to even get this wording to be legible. But my handwriting, and trust me, is much better than this. All right, last kind of example here. So we have a picture frame surrounding a picture is 2 inches wide. The picture inside the frame is 7 inches longer than it is wide. If the original area of the frame or if the overall area of the picture and frame is 198 square inches, find the dimensions of the picture inside the frame. So let's kind of draw out, ooh, this is going to be tough again using this tablet here, but let me kind of draw out what's going on. So we have this picture, and then we have a frame surrounding the picture. Let's just assume that's uniform. So the frame between here and here, is 2 inches. So it's basically, it's 2 inches all the way around. It says the picture inside the frame is 7 inches longer than it is wide. So let's just say the width of this guy right here is X. Then the length right here would be X plus 7, okay? Because it's 7 inches longer. And then on the outside of this, let me do that in a different color. On the outside from here to here is what? Well, we have X plus 7, but then we have another 2 inches here and another 2 inches here. So that's 4 more inches. So it's whatever X is plus 7 plus 2 and 2, so 11. And then from here to here, it would be X plus, well, just this is X, and then 2 and 2 is 4. So the overall area is 198 square inches. If we remember what area of a rectangle is, it's length times width, right? Or L and W. In this case, so they gave us that it's 198. The length is X plus 11 and the width was X plus 4. So we kind of have to solve this now. So we have our equation. Hopefully that makes sense to you. Let's distribute or FOIL this out. So we have X squared, X times X. X times 4 is 4X. 11 times X is 11X. And 11 times 4 is 44. So we have 198 equals X squared plus 15X plus 44. And now we're still solving this quadratic. So I want to have it as AX squared plus BX minus, or sorry, plus C. So we have to set this to 0. And I think, let me get my calculator. I need a calculator here. 44 minus 198 is 154. Oh boy, factors of, so now we need, so now we're trying to factor this. So we need factors of 154 that add to 15. Oh my, okay. Wow, I got it on the first try. That usually doesn't happen. 7 and 22 are actually factors of negative 154 that add to positive 15. So these two have to be a negative. So one has to be negative, one has to be positive, and it's obviously going to be the negative 7 there. So this factors into X minus 7. And then X plus 22. And then when we would solve this, right, we set these equal to 0. So we're going to end up with X equals 7 or negative 22. Well, negative 22 doesn't make sense for X, right? X is the width, right? And again, they wanted the dimensions of the picture inside, okay? So we just found that X equals 7, okay? So if this X is 7 right here, then the width is 7. And the width, actually, why don't I do that? So I'm actually going to erase this 7, I think. Let's see how this works out. Change it back to blue. So the width here is 7 because we found that with our X value. And then what's the length? Okay, what's the length? So what's this? It's 7 plus 7. So the length is 14 inches. Okay, so when we solve this equation, we were actually using the outside, the x plus 4 and the x plus 11. But they want the dimensions of the picture inside. Okay, so they want this guy and this guy. Okay, and that is it for section 6.6. If you guys have questions, please let me know. I know sometimes those word problems can be a little bit confusing. So we have one more section in chapter 6, and we'll do that next time. So thanks for watching.